The M-14 rifle, 7.62 millimeter, is a lightweight shoulder weapon. It is somewhat similar to the M1 rifle in functioning and appearance, but with additional characteristics of other small arms. The M-14 rifle is designed for both full automatic and semi-automatic fire. In semi-automatic fire, each squeeze of the trigger fires one round. By turning the selector to full automatic, fire is continuous as long as the trigger is held back and there are rounds in the magazine. One of the objectives in developing the M-14 was to provide a weapon which would use the 7.62 millimeter ammunition, standardized for small arms by the NATO nations. The 7.62 millimeter cartridge is 1/2 inch shorter and 12% lighter than the familiar caliber 30 M1 rifle cartridge, but due to an improved propellant powder, it has the same ballistics. The M-14 rifle has many of the characteristics of several older weapons. They are the M1 rifle, the previous standard of the United States Army since World War II, the Browning automatic rifle, the carbine, and the submachine gun M3A1. The M-14 rifle will, in time, replace these 4 weapons. The adoption of the M-14, one basic weapon, greatly reduces logistical problems. Moreover, it reduces time for training the user and small arms maintenance personnel. The new weapon has a 20-round magazine which is quickly and easily replaced. Before removing an empty magazine, the safety is placed on safe. The empty magazine is removed and a loaded magazine is snapped into place so that it is engaged by the rear of the operating rod spring guide and the magazine latch. Now allow the operating rod spring to force the operating rod forward, carrying the bolt with it, to chamber the first round and lock the bolt. The rifle is now cocked and ready to fire when the safety is off. The magazine also can be replenished from the top with clips of 5 rounds each without removing the magazine from the weapon. To speed up the loading operation for continued firing, the bolt is held to the rear automatically for reloading after the last round in the magazine is fired. This is accomplished by the upward pressure of the magazine follower, forcing the bolt lock into position in front of the bolt. This holds the bolt to the rear while the change of magazine takes place. By pulling slightly to the rear on the operating rod, the rifleman allows the bolt lock spring to expand, pivoting the bolt lock out from in front of the bolt. This also releases the operating rod. As the operating rod is released, it is driven forward by the expanding operating rod spring, taking the bolt with it. The bolt strips the first round from the magazine for chambering. Another feature of the M-14 is its flash suppressor. Slots in the suppressor act to break up the escaping gases, thus reducing the flash. The suppressor also acts as a muzzle brake, minimizing recoil and giving maximum stability during firing. This is the way the flash suppressor works. Gas strikes the wide bottom rib of the flash suppressor and exerts downward pressure to keep the rifle stable during firing. Of course, gas escapes in all other directions too. When the propellant gas hits the front of the slots, it tends to pull the weapon forward, reducing recoil. By disassembling or field stripping the weapon, you will become familiar with the parts. To field strip it, first clear the weapon. That is, remove the magazine and check to see there is no round in the chamber. Put the safety in the safe position. Turn the rifle upside down with the muzzle pointing to your left. To remove the firing mechanism, grasp the rear of the trigger guard and pull to your right and pry upward. Then swing up the trigger guard and lift out the firing mechanism. Separate the stock from the receiver by placing your left hand on the gas cylinder and lifting upward on the butt of the stock. The rifle is now field stripped into its three basic groups. The firing mechanism assembly, the stock group, and the barrel and receiver group. To further disassemble the weapon into individual parts, turn the barrel and receiver group on its side with the connector assembly up. To release the connector assembly, press forward on it with the right thumb until the forward end can be lifted off the connector lock. Rotate the connector assembly clockwise until the slot at the rear end is aligned with the elongated stud on the sear release. Then slightly lower the front end of the connector and lift it from the sear release. To remove the operating rod spring and spring guide, pull forward on the operating rod spring, relieving pressure on the connector lock. Pull the lock outward. Then remove the operating rod spring and spring guide. Now turn the barrel and the receiver group so the sights are up. Retract the operating rod until the guide lug on its lower surface aligns with the disassembly notch on the receiver. Lift the operating rod out and to the rear, disengaging it from the operating rod guide. Then, to remove the bolt group, grasp it by the roller, and while sliding it forward, lift it upward and outward to the right front with a slight rotating motion. The barrel and receiver group is now field stripped into the connector assembly, the operating rod spring and guide, the operating rod, and the bolt. These basic groups may be further disassembled if required. The rifle is assembled by reversing the procedure. After reassembly, the rifle should be hand-operated without ammunition to check for freedom of action of the components. The M-14 is gas-operated. That is, some of the gas formed by the firing of the cartridge is bled to the gas cylinder. In the gas cylinder, the gas inside the piston expands. The piston drives the operating rod to the rear, compressing the operating rod spring. Then the compressed operating rod spring expands, driving the operating rod to its forward position. This combination of backward and forward movements initiated by the firing of each cartridge performs a series of steps known as the cycle of functioning. The cycle of functioning can be broken down into 8 steps. Of course, these are performed as integrated and overlapping actions. The first step is feeding, which is positioning the cartridge ready for chambering. The second step is chambering, seating the round in the chamber. Third step is locking the bolt to the barrel, thus holding the cartridge seated in the chamber so that gas pressure will be maintained in the barrel to propel the bullet. The fourth step is firing, ignition of the primer of the cartridge in the chamber. Step 5 is unlocking the bolt from the barrel. Step 6 is extraction of the empty cartridge case from the chamber. In step 7, the empty cartridge case is ejected from the weapon. And step 8 is cocking in preparation for the firing of the next round. These 8 steps happen one after another, and so rapidly as to be almost simultaneous. By using a schematic drawing, we will see how these 8 steps are performed. To start the feeding step, the bolt is moved to the rear. A cartridge from the magazine is fed into position for chambering by the spring-loaded follower in the bottom of the magazine. On the forward movement of the bolt, the hammer is cocked and a cartridge is stripped from the magazine. The cartridge is chambered. The bolt is locked. The rifle is now cocked and ready to be fired when the safety is off. By pressing the trigger, the hammer is released, firing the cartridge. Part of the propelling gas escapes to the gas cylinder. The expanding gas in the gas cylinder drives the piston and operating rod to the rear and the bolt with it. On this rear movement, the bolt is unlocked. The spent cartridge is extracted from the chamber and ejected from the rifle. At the same time, the hammer is again cocked and the cycle ready to start over. Now, let us see in greater detail how the 8 functions or steps are performed. When we move the bolt to the rear, by hand initially, the bolt clears the top cartridge in the magazine. The magazine spring exerting pressure against the follower forces the top cartridge up in front of the bolt in position for chambering. Let us look at it again. When the bolt is moved to the rear, the bolt rotates. Rotation of the bolt during unlocking cams the hammer slightly rearward. It also moves the firing pin rearward as the firing pin tang contacts the camming surface on the bridge of the receiver. As the bolt continues to the rear of the feed rib on the bottom of the bolt forces the hammer to the rear and down, pivoting the hammer on the hammer pin. The bolt continues rearward, riding over the hammer. The bolt is now driven forward by the expansion of the compressed operating rod spring. The bolt strips the topmost cartridge from the magazine. The cartridge is deflected upward by the feed ramp in the lower rear of the chamber and forced into the chamber. Also, on the forward movement of the bolt, the extractor on the bolt face is forced outward by the rim of the cartridge. When the face of the bolt comes against the head of the cartridge, the extractor spring expands and the lip of the extractor engages the extracting groove of the cartridge. Finally, the bolt is locked. Locking of the bolt is accomplished by the rear of the camming surface in the hump of the operating rod. The camming surface contacts the anti-friction roller on the locking lug and rotates the bolt clockwise. By the clockwise rotation, the locking lugs on the bolt are forced into the locking recess of the receiver. Meanwhile, the firing pin tang is aligned with the notch in the bridge of the receiver. The operating rod continues its forward movement for 3/8 of an inch. During chambering and locking, the operating rod is repositioning the gas piston. With the first round chambered and locked, the next step is firing. Firing, of course, is initiated in the firing mechanism assembly. The firing mechanism assembly consists of the hammer, the hammer spring, which drives the hammer and which is compressed when the hammer is cocked, the hammer hooks, which are held by the trigger lugs, the safety, which engages the hammer and blocks movement of the trigger when in the rear safe position, and the sear. The movement of the bolt to the rear forced the rear hammer hooks into engagement with the sear, which prevents the hammer from following the bolt forward. When the trigger is released, the front hammer hook will be engaged by the trigger lugs as soon as the sear releases the rear hammer hooks. When the trigger is squeezed, the trigger lugs release the hammer hooks so that the hammer spring can drive the hammer forward. The hammer strikes the tang of the firing pin and moves it forward. The firing pin strikes the primer on the base of the cartridge, igniting the powder. When the cartridge is fired in the chamber, gas pressures build up. And a gas pressure of 50,000 pounds per square inch is exerted in every direction. It cannot escape to the rear because the locked bolt holds the case in the chamber, and the brass case is expanded against the chamber walls, effectively sealing the chamber. The gas can only escape by propelling the bullet out through the muzzle of the rifle. Near the muzzle is the gas port in the barrel, and as the bullet clears the gas port, part of the gas is bled off, entering the gas cylinder and piston. As gas enters the piston, it expands into the gas cylinder plug. Continued expansion of gas builds up a pressure which forces the gas piston to the rear. The initial rearward movement of the piston shuts off the barrel gas port. The pressure exerted against the piston drives it to the rear 1 1/2 inches. As the piston clears the lower gas port in the gas cylinder, the gas pressure instantly vents to the open air, removing all driving force from the piston. During the 1 1/2 inch movement of the piston rearward, the piston is forcing the operating rod to the rear. After completion of piston travel, the force of inertia causes the operating rod to continue to the rear until the termination of recoil. Recoil ends when the shoulder of the operating rod contacts the front end of the receiver. The operating rod spring now expands and forces the operating rod forward in preparation for firing of the next round. In the forward movement, the front end of the operating rod repositions the gas piston, which comes to rest against the gas cylinder plug. To see how unlocking was accomplished, we will repeat the action. When the operating rod moved rearward, it accomplished several things, the first of which was the unlocking of the bolt. Before the bolt starts to unlock, the operating rod permits 3/8 of an inch of free travel to the rear. This is a safety factor, permitting the bullet to leave the muzzle and gas pressure to subside before unlocking begins. This prevents gas from blowing back into the rifleman's face when the bolt unlocks. At the completion of free travel, the front of the camming surface in the hump of the operating rod comes in contact with the anti-friction roller on the right locking lug. This rotates the bolt counterclockwise, forcing the locking lug on the bolt out of the locking recess in the receiver and unlocking the bolt. While the bolt is being unlocked, slow initial extraction takes place. The rim of the cartridge case is gripped firmly by the extractor. A slow twisting pull called slow initial extraction is imparted by the rotating bolt. Remember that at the moment the cartridge was fired, gas pressure of 50,000 pounds per square inch expanded the brass cartridge case tight against the chamber walls. It also forced the head of the cartridge case against the face of the bolt. To pry the cartridge loose, the slow twisting pull is required. It begins just before unlocking is completed. The corresponding radii of the locking lugs on the bolt and the locking recesses of the receiver, along with the rotation of the bolt, allow a slight rearward movement of the bolt. This rearward twisting action loosens the case in the chamber and causes slow initial extraction. When the bolt continues to the rear, following unlocking and extraction, the spent cartridge is ejected. This is the ejector in the face of the bolt. The ejector spring is compressed when the ejector is held flush against the face of the bolt. When a round is in the chamber and the bolt is locked, the head of the cartridge compresses the ejector spring. During extraction, the chamber wall holds the neck of the expended cartridge case in line with the bore. But when the neck of the cartridge case clears the chamber, the ejector spring is allowed to expand. The ejector forces the empty cartridge case to pivot about the extractor, ejecting it from the rifle. After the spent cartridge is ejected, the bolt continues to the rear over the rounds in the magazine. The rounds are under pressure by the follower. When the bolt begins its forward movement, the hammer is cocked and the cycle is then repeated. Feeding, chambering, locking, firing, unlocking, extracting, ejecting, and cocking. The cycle of functioning we have demonstrated is the same whether firing is semi-automatic or full automatic. In semi-automatic fire, the trigger must be released each time before another round can be fired. In full automatic fire, cartridges are fired continuously as long as the trigger is held to the rear. Let's see how the mechanism of the rifle can be adjusted to fire either single shots or bursts. To see how the firing mechanism operates, we will use an oversized model. If the firing mechanism assembly were operating at normal speed, recoil would happen so fast that no rifleman firing single shots would have time to release the trigger in preparation for the next single shot. To overcome that, the sear is provided. The sear catches the hammer hooks even though the trigger is still being squeezed. When the trigger is released, the rear hammer hooks are released from the sear, and the front hammer hooks are engaged by the trigger lugs. The weapon is now cocked and ready to fire again when the trigger is squeezed. To achieve full automatic fire, there must be some way to trip the sear after the bolt is fully locked, while the trigger is being held back. This is done by the selector, the sear release, and the connector assembly. The selector sets the mechanism for either semi-automatic or full automatic fire. When the selector is set in the full automatic position, the connector forces the sear release to trip the sear. In the last 1/8 of an inch of forward movement of the operating rod, the rifle will continue to fire automatically as long as the rifleman holds the trigger to the rear. When the trigger is released, the front hammer hooks are engaged by the trigger lugs on the next rearward movement of the hammer, and the weapon ceases firing. M-14 rifles equipped for full automatic fire have a selector marked A. To fire full automatic, the rifleman turns the selector so that the letter A faces him. By pressing in on the selector and giving it half a turn so that the letter A is away from him, he sets it for semi-automatic fire. When turning the selector to semi-automatic, the movement of the selector rotates the sear release forward on an eccentric shaft approximately 1/8 of an inch, so that it cannot trip the sear. It causes the connector assembly to move far enough forward so there is no contact between the operating rod and the hook of the connector assembly. This positions the sear release so it cannot contact the sear. At the discretion of the unit commander, the M-14 rifle may be issued to troops either with the selector or with a selector lock like this one, which permits only semi-automatic fire. In summary, the M-14 rifle fires the standard NATO 7.62 millimeter ammunition for small arms. It fires semi-automatic, one shot each time the trigger is squeezed. And it can also be set to fire full automatic. That is, delivering continuous fire as long as the trigger is held back and there are rounds in the magazine. The M-14 rifle was developed to incorporate important features of these 4 battle-tested weapons and to replace them. The M-14 has great firepower and versatility. It gives reduced weight, ease of logistical support, great reduction in training time, and most important, increased firepower for the individual rifleman.